The objective of this lesson is to convert measurement units between measurement systems using ratio reasoning. When calculating answers to measurement conversion problems, we often find the solution to be a decimal. Answers might have slight variations when students decide to round their decimal to the tenths or hundredths place instead of using the exact equivalent decimal. For example, 1 kilogram is approximately equal to 2 2/10 pounds and can be used instead of 1 kilogram equals 2.2046226218 pounds. The two wavy lines symbol means approximately equal. Let's look at an example. A baby visits a doctor for a checkup. The baby's weight is measured and recorded. The baby weighs 7 8/10 kilograms. How much does the baby weigh in pounds given that 1 kilogram is approximately equal to 2 2/10 pounds? One strategy that can be used to solve this measurement conversion problem is a ratio table. In this table, we can see that 1 kilogram equals 2 2/10 pounds. We multiplied 1 times 2 2/10 and got 2 2/10. For 7 8/10 kilograms, we again multiply by 2 2/10 and get the answer of 17 16/100. Therefore, 7 8/10 kilograms is equivalent to 17 16/100 pounds. Here is another example. A baby visits a doctor for a checkup. The baby's length is measured and recorded. The baby is 25 inches long. How long is the baby in centimeters? 1 inch approximately equals 2 54/100 centimeters. Another strategy that can be used to solve this measurement conversion problem is the double number line. The first line represents inches, and the second line represents centimeters. If 1 inch equals 2 54/100 centimeters, then how many centimeters is 25 inches? 5 inches would be 5 times as many, so it is also 5 times as many centimeters, which is 12 7/10 centimeters. We increase by sets of 5 inches and sets of 12 7/10 centimeters until we come to 25 inches. 25 inches would be 63 5/10 centimeters. Let's solve one last problem. How long is a 5K race in miles? Notice that 1 kilometer is approximately equal to 62/100 miles. We can solve this problem using either a double number line or a ratio table. To use a double number line, we make two parallel lines and label the top 1 kilometers and the bottom 1 miles. We mark 0 on the top and bottom to begin our model. Next, we mark off 1, 2, 3, 4, and 5 kilometers on the top number line. On the bottom number line, we record that 1 kilometer is equal to 62/100 miles. 2 kilometers is equal to 2 times 62/100, or 1 24/100 miles. 3 kilometers is equal to 3 times 62/100, or 1 86/100 miles. 4 kilometers is equal to 4 times 62/100, or 2 49/100 miles. 5 kilometers is equal to 5 times 62/100, or 3 11/100 miles. We can also solve this problem using a ratio table. If 1 kilometer is equal to 62/100 miles, we can see that we need to multiply by 62/100 to find the answer. 5 kilometers times 62/100 equals 3 11/100 miles. The objective for this lesson was to convert measurement units between measurement systems using ratio reasoning. We met this objective by solving real-world problems and by using ratio reasoning and strategies such as ratio tables and double number lines.